and good day, geometry. We are going to wrap up the week with a recorded lesson on CO40, which is using the Pythagorean theorem in other ways than just its main purpose, like we talked about in PO39. CO40 is the only non-power objective of the entire unit. So if there's any lesson to zone out and ignore, this would be the one. Don't do it, but it would be the one. Okay. Anyway, so in PO39, we talked about the Pythagorean theorem, which says that if a triangle is a right triangle, then a squared plus b squared equals c squared. If a triangle is a right triangle, then that relationship exists between the legs and the hypotenuse, that the sum of the legs squared, or the sum of the squared legs, equals the hypotenuse squared. And so we were given a whole bunch of right triangles. We knew they were right triangles going in, and we plugged in values for A, B, and C and solved for missing sides. Okay? Well, the converse of the Pythagorean theorem, which if you think back to CO12, converse just means that the if and the then statement are switched. So the converse says that if, and I'm going to write it this way for a reason that I mentioned in PO39, but we'll expand on here in CO40, if c squared equals a squared plus b squared, then the triangle is a right triangle. If c squared equals a squared plus b squared, then the triangle is a right triangle. The converse of the Pythagorean theorem is used so that if we know the three sides of a triangle, we can determine whether or not the triangle is a right triangle. If we know what a, b, and c are, we can test to see if a squared plus b squared does in fact equal c squared, then we know the triangle is a right triangle. If a squared plus b squared doesn't equal c squared, then we know it's not a right triangle. And we can take this a little bit further to also determine if a triangle is acute or obtuse. And that's where theorem 7.3 and 7.4 come into play here. Theorem 7.3 says that if c squared is less than a squared plus b squared, then the triangle is acute. Theorem 7.4 says that if c squared is greater than a squared plus b squared, then the triangle is obtuse. So, I mean, c squared can only be one of three things when comparing it to a squared plus b squared, right? If c squared is equal to a squared plus b squared, then the triangle is right. And if c squared is less than that, it's acute. If c squared is greater than that, it's obtuse. Those are the only three options for what c squared can be when compared to the value of a squared plus b squared. And the reason why I wrote it here with the c squared first is to kind of use the less than and greater than signs to help us remember which one's associated with acute triangles and which one's associated with obtuse triangles, right? C squared is less than, think less than 90 degrees, it's going to be an acute triangle. If c squared is equal to a squared plus b squared, which is what the Pythagorean theorem says, if it's equal, think equal to 90, it's going to be a right triangle, right? If c squared is greater than a squared plus b squared, think greater than 90, and it's going to be obtuse. So writing it this way, seeing that less than symbol, c squared is less than a squared plus b squared, less than acute. C squared is greater than a squared plus b squared, greater than, the brain tends to associate that with obtuse. C squared is equal to a squared plus b squared, that equal to, well, that's our right triangle, okay? So before we go on down to the section below, how do you know which values to use for A, B, and C? We touched on this in PO39. C, being the hypotenuse, is always going to be the longest side every single time. And remember that A and B are interchangeable, right? They're just the legs. It doesn't matter which one's A and which one's B, because you square each of them and then add them together. Whether you square A first, then B, then add them together, or you square B first, then A, and add them together, you're going to get the same result. Okay, but that longest side, always the hypotenuse, always side C. So let's look at the three examples here. Do the segment lengths form a triangle? If so, is it acute, right, or obtuse? And show your work. I want to scroll down a little bit here so we can get the rest of the page. Okay, 10, 11, and 14. I'm going to start by labeling my A, B, and C. I know that 14 is my C, being the longest side. It doesn't matter which one of these is A and which one's B. But putting it into the Pythagorean theorem here, I can't really go as far as to say that C squared equals A squared plus B squared, because that's kind of what I'm trying to determine. What is the relationship of C squared? So I'm going to put a question mark above this, just to say, you know, is C squared equal to A squared plus B squared? And if it's not, right, then what is that relationship? So 14 squared is 196. 10 squared is 100. 11 squared is 121. Just plugging in 10, 11, 14 in for A, B, and C, and then squaring each of them. And is 196, what is that relationship? I really shouldn't put this equal sign here quite yet. I want to keep that open because we don't know if it's equal or not. But what is the relationship between 196 and 221? Well, 196 is less than 221. So the value of C squared is less than the value of A squared plus B squared. Therefore, this triangle with side lengths of 10, 11, and 14 is going to be acute. On to the next one. We have not really had much experience with roots yet. We talked about simplifying them a bit in PO39, but I don't think we're quite ready yet to use them in this capacity. So I want you to cross out 4, root 3, and 8, and just kind of change this to be 4, 5, and 8. So those are the three side lengths that we're going to use here, 4, 5, and 8. Again, I'm going to identify my A, B, and C, C being the longest side. These two are interchangeable, so it doesn't matter which is which. And we're going to be testing here. What is the relationship of C squared? Again, I'm going to put a little question mark above. To A squared plus B squared. Well, my C value being 8, I'm going to square that. That gives me 64. A squared, my value for A is 4. 4 squared is 16. B squared, my value for B is 5. 5 squared is 25. And so I get 64, and I'm comparing that with the sum of 16 plus 25, which is 41. 64 is greater than 41, and because C squared is greater than the sum of A squared and B squared, I know that this triangle with those side lengths is going to be obtuse. Similar start with this last one. We're going to cross out 5, 6, and root 61, and we're going to use 16, 30, and 34. If you haven't had to use your calculator yet, you want to go ahead and square these things. So we have our A, B, and C again. They are given to you in order. So we're comparing C squared. We want to know, what is that relationship? Is it equal? Is it greater than? Is it less than? To A squared plus B squared. 34 is our value for C. 34 squared is 1,156. Quick maths. A squared, 16 squared is 256. Plus 30 squared, which is 900. And it turns out that 256 plus 900 is equal to 1,156, making these two values equal. And since c squared is equal to a squared plus b squared, we know that this triangle with these side lengths, not only is it right, it's a Pythagorean triple, right? Because they're all integer values or whole number values there. So we have an example of each type here, where c squared is less than the sum of a squared and b squared, meaning the triangle is acute. C squared is greater than a squared plus b squared, meaning the triangle is obtuse. C squared is equal to a squared plus b squared, which means the triangle is a right triangle. One example of each situation. Okay, so other uses of the Pythagorean theorem. Here we thought it was just an equation that related to right triangles. Well, turns out not so much. It's bigger than that. It can help us determine whether any triangle, if we know all three of the side lengths, whether that's going to be an acute, obtuse, or a right triangle. So your assignment, and again, we're off next week for geometry to allow for folks staying after for retakes. So if you normally stay after a Monday for geometry, you know, why not stay after on Monday to do some geometry retakes? If you normally stay after on Wednesday, why not stay after Wednesday to get some retakes completed? That's why you have that opportunity. But your homework is going to be on page 444. I would like you to do 18 through 23, where you are just plugging values in for A, B, and C and determining whether or not the triangle is acute, right, or obtuse. Well, first, actually, the directions there say decide if the segment lengths form a triangle. So you have to make sure that the three segment lengths can form a triangle. Kind of goes back to PO30 a little bit there. And if they can, then say what type of triangle it is. Actually, you know what? Let's not stop at 23. Let's go to 25, since it's the perfect square and everything. Why not? And then I think that'll be it. Yeah, just page 444, 18 through 25. That'll be due next week, or the week after next, after the end of the trimester. That's how you math, folks. Don't forget to like and subscribe, and have a great day.